Welcome students. In engineering geology we are seeing about the 4th unit. In the past classes we have seen about the earthquake, landslide, what are its effect, why it is formed and what is the precautions that we have to make. And we also saw about the groundwater, right? So the groundwater we saw about the water table, cone of depression, geological controls of groundwater movement and groundwater exploration techniques. Last class we saw about the groundwater, what is a saturation zone, what is unsaturation zone. So maybe in the water table, cone of depressions, other things, we will see the same thing once again but in a different perspective. Okay. So here we can see the groundwater, it is the science of occurrence, distribution and movement of water below the earth's surface. So water will be precipitated and it is infiltrated through the gravels and the sand and it forms the saturated zone which we call it as the groundwater. Right? So the main source is precipitation. Precipitation is mainly because of the rain and snow. Right? That we saw already. And discharge of the groundwater, it is due to two reasons. One is natural way, that is it is flow into the lakes like this, or it will flow into the rivers, lakes, oceans and springs. Artificial way, we will have the pumpage from the wells. Right? So, why the main thing it is groundwater is so important, it is that it doesn't have any adverse properties, that is turbidity, objectionable colors, pathogenic organisms are not there. It is also safe from hazards of chemical, radiogenic, biological pollution in which surface water bodies are exposed, and supplies are quickly affected by drought and other climatic changes. And it is more dependable. It is used for most of the region for the drinking purpose and other purpose. This class we will be seeing about the water table. Okay, the first topic. The water table is the free water surface in an unconfined aquifer, indicating the level of water table at that point. The water table is constantly in motion, adjusting to its surface to achieve a balance between the recharge and outflow of the surface. Okay, if it is a mountain is there now, the water table will move along this one and it is like this, it will move now. It won't be there as a straight line. It moves along with the discharge and also it depends upon the infiltration capacity, what is the runoff, everything. It depends. It gives a balance between the recharge and the outflow from the surface drainage. So here you can see. So this is the water table. You can see here this line is the water table. Okay. So this is the above point we call it as the zone of aeration or zone of unsaturation. This thing we call it as the groundwater or we call it as a saturation zone. This zone is divided into three parts. We already know: soil mass, intermediate plain and the capillary fringe. So in between this confined aquifers, the top layer between the capillary fringe and the confined aquifer, unconfined aquifer, we got the water table. And what I want to tell you is that the water table is not a straight line. It moves along with the discharge and gives a balance between the discharge and the outflow. This is the form of stream, right? So you can see here, right? So as I told you, this is a Vadosol zone and this is a phreatic zone. In between there is a capillary fringe. Along the capillary fringe and the unconfined aquifer we have the water table. Mostly the wells will be below the water table. There will be a drawing of water from the unconfined aquifer for the well. You can see here the water, air, sand grains will be there in this part. Okay. So this also very clearly shows that mostly the discharge will be here and it flows along with this. There is a stream is there. So this is the water table. The blue color things will got in the water table. As I told you already, it is not a straight one. It is a curved one. The extent fluctuations in the water level in the duct belt during various seasons of the year. Lowering of the groundwater table in a region is due to the heavy pumping of the wells and the rise in the water table of the irrigated and the poor drainage are common examples of the fluctuations in the water table. So sometimes the rainwater will be very heavy. At the time the water table will be high. Sometimes there won't be any rainwater, but there will be a pumpage from the well and there will be so much of water drawn from that thing, which makes the water table go below. Right? The infiltration is also not there, so the water table will go below. So these are the common examples which is the causing of the fluctuations of the water table. Generally we talk of the follows the topographic features of the surface. The water table mostly follows the topographic features of the surface where the unsaturated zone and saturated zone meets. If the water table intersects the land surface, the groundwater comes out to the surface in the form of springs or seepage. Sometimes it falls now. If it is a ground surface, you feel that some type of springs that comes out. Right? This is due to the water table that is comes to the top of the ground surface. Right? So there will be a formation of springs. So you can see here, this is a recharge. Is also the water tables also depends upon the time period. Okay. So it is a recharge. The recharge infiltrates into the ground. So in the top layer, what happens? It is a mountain. In some years, this recharge will go into the top layer. But if it is a centuries, then the water will go down. If it is a millennium years, it will again go into the above the years also. It goes and it goes into the magma, and it comes out in the form of a steam as a discharge. So all the water table that is coming out will again always go in for the outflow, and it will again go in for either for evaporation or transpiration, or it reaches the stream or a pond or a lake or a ocean. Like that it will go. This is the path, groundwater path of the table. Right? So now we will see about the aquifer character of commonly occurring rocks. Three rocks we will see. One is the igneous rocks, sedimentary rocks and metamorphic rocks. Among different types of the igneous rocks, we know that there are subdivisions. There are plutonic layer, high-basal rock, volcanic rocks, granite, dolomite and basalts. For example, we see that there is two types. That is the exterior, that is volcanic, interior, that is the ordinary things. The formation of granites will be there. In exterior, the formation of basalt will be there. Right? Okay. So actually this granite and dolomite will not have the interlocking structures, where basalt will have the interlocking structures. So hence this granite will have a negligible porosity and permeability. It will not have a hard layer. So these rocks are typical examples of aquifuges. So we saw what is aquifer, what is aquifuge now. It is a very good layer of aquifer which will not have no water. It will have some water which will go in for seepage. They can be a groundwater only when they are intensively fractured, have undergone considerable weathering. It can hold water in the break, that is the cracks formation, and which cannot be drawn regularly, but it can ooze out because of the seepages. Okay. However, both weathering and fracturing decreases with depth and disappears. No groundwater can be expected in such rock at a greater depth. There will be only small amount of water that will be there in this igneous rocks, and these are vesicular, and these besides are considerable size and number, and these are interconnected. They can serve as an aquifer. If the cracks in the granite or basalt or this type of igneous rocks, if the cracks are interconnected with each other, then we can say that there will be some water that will be used as an aquifer. But mostly this is not possible, so it will not be used as an aquifer. It is used as an aquifuge. The contraction joints and fractures, if present, also contribute to the porosity and permeability character of igneous rocks. You can see here, there will be some cracks that are formation which holds the water into it. You can see here, it will hold the water here in the rock formation. The next one, it is a sedimentary rock. Already we saw that sedimentary rocks are sediments, formation of sediments layer. So already it will have some gaps in between which holds the water, and which will be mostly acts as an aquifer also. So some examples are shales, sandstones and limestones are the examples of sedimentary rocks. And here it is formed because of the deposition. So generalization may be made of coarse, rounded, sorted, less compacted and poorly cemented rocks. It won't be so much of tight, or it will not be so much compacted. So water will be available inside these rocks. In this case of dense and fine grained limestone, they will have no primary porosity, but cavities and channels are common in them. So even if the limestone doesn't have itself porosity, when it is connected with another, it forms a continuity of the pores which will helps in the permeability, increase the permeability, because these rocks are highly porous. All the foregoing rocks may have joints, faults, shear zones, cracks, etc., which contribute to the additional porosity in them. You can see here, this is a sedimentary rock, so it will have so much of gap where the water can be held in, and it can be used as an aquifer in most of the cases. In the sediments and sedimentary rocks, the following represents the increasing order of aquifer character: clays, shale, limestone, sandstones, sand and gravel. Shales are mostly impermeable rocks. Clay may have 50 to 60% of porosity, but limestone will have 80 to 90% of porosity. The next we will see about the metamorphic rocks. So metamorphic means change. So the rocks will have a completely different thing. Not a sedimentary, not an igneous. It is formed because of the high temperature and pressure. So that there will be lineation or foliation if it is there in this rock. Then it will hold the water in it, which will contribute to the porosity. But as such, rocks is formed under great pressure. Their force are very minimum, right? So primary porosity cannot be expected, but if there is any foliated structures in this rock because of the formation of because of the change in formation, then there will be some water that will be there, which will be active, right? Here you can see there is a foliated structures, so there may be water in the foliations, which will be acts as a aquifers. Okay. So these are the water tables, and then we saw first time we saw what is a water table, and the next one we saw what are the aquifer character of the commonly occurring rocks. Right? This is very important when we go in for the geological characteristics, to study the geological characteristics. Next we will see the cone of depression. For example, if I am going to take a well, right? If I am going to draw water, all of you know we will take a well, we will draw water out now. So when we taking water, the water level will be like this. Okay, whether the cone of depression or we call it as cone of exhaustion. So this is called as a cone. It forms a cone structure. So in any gravity well, that is a well that is for unconfined aquifer, when we are drawing the water out, the static level of water coincides with the water level, right? So it coincides with the water level of the surrounding aquifer. When water is pumped out in a considerable measure from the well, the level of water that is goes down, leading to the depression in the water table around the well in the form of inverted cone. So this phenomena is called as the cone of depression, or we call it as a cone of exhaustion. Again I am telling you, when water is pumped out in a considerable measure from the unconfined aquifers, okay, from the unconfined aquifers, then what happens now? The level of water in it goes down, leading to the depression in the water table around the well in the form of inverted cone. So with the temporary fluctuations in the level of water table, because the original position is restored within a short period, immediately it will form a cone of depression, but along the water table level, again it will bring to the same level. So due to the seepage of the groundwater from the sides of the field, that is called as the aquifer. The shape of this cone of depression on the water table around a pumped well mainly depends upon the permeability nature of the aquifer body. You can see here, this is a well, so this is aquifer. Mostly I told you now, this is a zone of aeration, or we call it as a zone of unsaturation. This is a zone of saturation to the point where we go in for the well. So when we are taking water into the well, I told you this is a water table level. Original water table level is this one. Original, initial water table level. But when I am going to draw water here, the water table comes like this in the formation of a cone, inverted cone. It forms in the inverted cone, which I call it as a cone of depression or cone of exhaustion. Right? This will be there for a there is a short period, after which it will come to its original position. So this I call it as a cone of depression, or I call it as a cone of exhaustion, which is very important in the case of a aquifer. That is a well that water drawn from an aquifer through a well at a constant rate, right? So this is a pumping level, well casing, well screen. This is a radius of influence. So where it comes now, that I call it as a radius of influence. Okay. So this I call it as the drawdown time. That is how much water I have taken. So this is a very important phenomenon when we study about the steady flow in a well, right? So next we will see about this. In the cone of depression, in case of permeable material, the cone of depression is nearly flat. When in less permeable aquifers is very deep. The boundaries of the cone of depression is known as the groundwater divide. The area enclosed by the groundwater divide is termed as the area of the pumping depression, right? So this I call it as the area of the pumping depression. Okay. So the distance between the well and the groundwater divide in terms of radius of influence. Mainly the radius of influence. This is a radius of influence. This is the water table level. So this is the cone of depression that is formed. So I take it as a from the center to this point I call it, from the center to this point I call it as the radius of depression, radius of influence. Okay. So we can see here, this is a groundwater aquifer, a well which is drawn, right? So this next one we will see about the geological controls of groundwater movement. Okay, so we have seen about water table, we have seen about the aquifer characteristics based on the rocks. Third one we saw about the cone of depression or cone of exhaustion. Fourth topic we are going to see is the geological controls of groundwater movement. The groundwater is the water that exists in the pores, places and fractures in rocks and sediments beneath the unsaturated zone, or we can call it as a lies in the saturated zone of soil which can freely into a well, tunnel, spring, etc. So what are the occurrence mainly depends, that is the controls of the groundwater. Number one, it is porosity. Number two, it is saturated and unsaturated zone. Third one, permeability. Fourth one, aquifer. The fifth one, it is the storage coefficient, which is also a property that depends upon the aquifers. Okay. So mostly all the things, that is the water will be available in an aquifer zone from which it has to be taken. So the saturation at the groundwater level is there with the one way or other it is. So the groundwater occurrence depends upon the porosity, saturated and unsaturated zone, permeability of soil, aquifer and the storage coefficient. We will see one by one. Porosity. So porosity is what all of you have studied already. Porosity is the number of pores that is available in a certain points, right? So it is amount of pore or open space between the soil particles. We call it as a porosity. The porosity is interconnected between one another. Then it forms the zone where the permeability will be more. If the porosity is very less, that is number of pores or number of free space is very less, then the permeability will not be happening. If the porosity is more, then the easily it can be, the water can easily flow. For example, if I am going to have a gravel at one point, right? So I can have a gravel. Gravel will be having a very big stones, right? Then I have a sand, okay? Sandy layers, I have sand, okay? The third one I have soil. Soils will have not pores, okay? It will have pores, okay? So where the water will flow very high, it will flow here very high because there will be so much of zones that is easily can be flow. Here it will already flow because follow the gap where it is there and it will flow, right? But here it is no continuity of pores are there, so it won't be there in a compacted soil. Similarly, in sediments or sedimentary rocks, the porosity depends on the grain size and shape of the grains, the degree of sorting and the degree of cementation. Cementation, how hard the soil is, depends upon this the porosity will be there. In rocks, the porosity depends upon the extent, spacing, pattern of cracks and fractures. Well-grounded or well-rounded, coarse-grained sediments usually have a very higher porosity, because if it is uniformly grounded means it will not have sufficient space to things. But if it is having a irregular shapes means one will be like this, another will be like this, third one will be like this, so the pores will be can be controlled. Okay, it will be fit to one another. The second point, the first one it is a porosity. If the porosity is very high, then the groundwater movement will be very high. That is number one. Number two, saturated and unsaturated zone. Again we are coming back to the saturated and unsaturated zone. Saturated zone is the having a groundwater that is fully of water. Unsaturated zone is of three layers: soil, subsoil, and the intermediate layer and the capillary fringe. In between the zone, saturated zone and unsaturated zone is the water table is found, right? Okay. So this is again we are going to see this. You can see here. So water infiltrates. These are the unsaturated zone or zone of aeration. This is the saturated zone where it is completely filled with water. This is the water table. Okay. So here it is there. Unsaturated zone is there. Okay. You can see here. This is the water table. It is a saturated zone. Here only the wet tables are there. Okay. Saturated zone is also known as the groundwater zone, as I have already told now, where all the pores of the soil will be filled with water. The water table forms the upper limit, marks a free surface, that is a surface having the atmospheric pressure. Unsaturated zone are called as the zone of aeration, in which the soil pores are only partially saturated with water. It will be infiltrated into the saturated zone. The space between the land surface and the water table marks the extent of this zone. The zone of aeration having three subzones. One is the groundwater or soil water zone or soil zone, I told you now, where the water gets infiltrated. It will have the gravels and the sand in it. The next one, it is the intermediate zone, that is where the water gets infiltrated through the thing. Here if the porosity is very high, then the permeability will be also very high. It depends upon the porosity of the material. If the gravel and sand is there, the porosity will be very high, right? Okay. The next one, it is the capillary fringe. Due to the capillary action, this water will be poured out. Mostly this trees and other things in the desert regions are where the trees needs more water. It will absorb the water, or it will take the water from the saturated zone with the help of this capillary fringe. So here the third layer is a capillary fringe, and this is a water table, right? This is a water table below which there is a groundwater aquifer. We call it as a groundwater, or we call the main thing as an aquifer, and it is a zone of saturation. This is zone of aeration, or we call it as a zone of unsaturation. Unsaturation zone is not completely, it is a partially saturated zone. The first one, it is a soil water. I told you. The next one, capillary. The second one is intermediate zone. The third one, it is the capillary fringe. Here also the same thing I have told you. This is called as a zone of aeration or unsaturated zone, or we call it as a Bedosol zone. Here this is a water table, underneath the zone of saturation, or we call it as the zone of saturation, or the phreatic zone, or we call it as a saturated zone. Okay. So the same thing I have pictured, I have shown you here that the water will be very less in the case of a soil that is unsaturated zone. In the case of saturated zone, you can see that all the particles will be completely filled with the water, right? It will be partially filled in the case of the intermediate zone, right? The third factor, the first factor we saw about the porosity, the second factor we saw about the saturated and unsaturated zone. The third one we'll see about the permeability. So the permeability is a measure of soil's ability to permit water to flow through its pores or the voids. Knowledge of the permeability of the soil necessary to estimate the quantity of underground seepage, solving problems involving pumping seepage water from construction excavation. So what are the factors affecting the permeability of the soil? Number one is the grain size. So the grain size, the smaller the voids and thus the lower the permeability. So as I told you that with the gravels, the size is very big. It cannot fit to one another. The permeability will be very low, very high. With the sand, I told you that somewhat the particles are very small compared to the gravels, and hence it is having some porosity. The water will flow through it. But coming to the third one, the compacted soil, which is very hard and it does not allow the water to pass through, the porosity will be very less. So smaller the grain size, lesser the porosity. Okay, smaller the grain size, smaller the voids and thus the lower the porosity. That is with the help of grain size. Next one, it is a voids ratio. Voids ratio is the porosity. So when the porosity is higher, permeability will be higher. So increase in the porosity leads to the increase in the permeability. Second one. Third one, composition. So the influence of soil composition and permeability is generally insignificant in the case of gravel, sand and silt unless mica and organic matters are present. So if it is containing gravel, sand and silt means the soil will be easily porous. But with the help of mica or organic matters, this will not allow the continuation of the pores and hence it will have a very less porosity. So this is that is the thing is the third point is the composition of the soil layer. The next one is the soil structural. Fine grained soils with a flocculated structure have a higher coefficient of permeability than those with a dispersed structure. All of you know, I told you that this depends upon the grain. So if it is a fine grained soil, then the coefficient of porosity will be less. The degree of saturation, higher the degree of saturation, higher the permeability is there. And presence of entrapped air and foreign matters reduces the porosity. Right? If that is what it is there, it is mainly mica and organic matters forms into the foreign matters which will block the pores and it will not allow the water to pass through, so it reduces the porosity. So the grain size, void ratio, composition, soil structure, degree of saturation and presence of entrapped air are the factors that affects the porosity of the soil. Hence it is the it controls the movement of the groundwater. The three things we saw, one is porosity, saturated and unsaturated zone. The third one we saw is the permeability. The next one we see is about the structural formation. So this is the four things: aquifer, aquihad, aquiclude and aquefuge. All of you know, here you can see here the water flows. The first layer in the saturated zone is the unconfined aquifer. This is the aquifer which forms a layer that is a dense layer in between, which we call it as aquifer, and when it is confined between two layers, we call it as an unconfined aquifer. This will have more water, it will have a less water, it stores the water but it will not allow most water to go through. But here this will also have more water. Mostly the artesian wells will be like this and it will get the water out. We can see the movement of the water will be there in the confined aquifer and unconfined aquifer. But with aquifer it can hold the water but it will not allow the movement of the water. Right? I told you now the artesian bores will be there till the unconfined aquifer to get the water. Right? So here the next we will see it's a aquiclude. Aquiclude is the last layer which is a impermeable layer which holds the, that is a very hard layer below that. We call it as a aquiclude. It is maybe a clay layer which will hold some water in it. But coming to the aquefuge, it is neither hold water nor it will transmit the water. It is like that of a rock, right? Hard bed rock, we call it as the aquefuge. So aquifer is of two types. One is the confined aquifer, the next one it is the unconfined aquifer. As I already told you now, aquifers, unconfined aquifer is one in which water table varies in undulating form in slope and depends upon the discharge. So from where the water, it is a top layer of zone of saturation from which water can be withdrawn. So the aquifer will be having this cone of depression, rising and falling of the water table will be there with the unconfined aquifers. Okay, so unconfined aquifers, and it is with the confined aquifers. This I told you na, aquifer water table varies in undulating from its slope, depends on areas of discharge and recharge and permeability. Next one, it is mainly this unconfined aquifers depends upon the topography of the structure. Okay, it depends upon the topography. Okay, so the next one, it is a confined aquifer. So confined aquifers also known as artesian or pressure aquifers, where the groundwater is confined under pressure. That is, it is confined under two hard layers. This is an aquifer, this is a aquiclude. In between the aquifer is there, this is a confined aquifers. It is under the pressure between the two things. So what is the importance of this aquifer? To transmit groundwater from areas of recharge to areas of discharge. To provide a storage medium of usable quantities of groundwater. The amount of water a material hold depends upon its porosity, as I told you already. So this is the unconfined aquifer. This is unconfined aquifers. This is aquifer. This is between two layers. We call it as a confined aquifer. This bottom layer is made up of mostly clay. We call it as a aquifuge. So here also you can see here. This is an unconfined aquifer, and it is a aquiclude. Next one, it is aquifer. Aquitard is the partly permeable geological formation. It transmits water in such a slow rate that the yield is insufficient. So here it will allow water, it will hold water, slowly the water will be discharged due to seepage. The movement of water will be more in unconfined aquifer and a confined aquifer compared to the aquifer. The aquiclude is impermeable of the soil. It will absorb the water slowly, but it will not transmit. Right? This is the bottom layer. Mostly it will be of aquiclude. Right? So it will be mostly a clay layer. You can take it as aquiclude. There is some problem with the screen. Aquifuge is a geologic formation which does not have interconnected pores. The last layer we call it as the bed. We call it as the aquifuge. It neither store water nor transmit this. It neither store water nor transmit the water. Example of aquifuge are rocks like basalt granite without fissures. If it is having cracks, it acts as an aquiclude. But if it is not having any cracks, fissures, if it is a very good bedrock, then it will act as a aquifuge. Aquiclude and aquifuge. There are another two terms, that is we call it as a leaky aquifer and perched aquifer. The aquifer bound by one or two aquicards is known as the leaky aquifer. It is also known as a semi-confined aquifers. Right? So it will have the aquicard then and there break, so that this will act as a semi-aquifers. The perched aquifers is a special type of unconfined aquifer. A permeable saucer-shaped stratum in a small areal extent occurring in the zone of aeration and may retain or hold some amount of water. We call it as a perched aquifer. So this is the unconfined aquifer. This is the water table. Above the water table there will be some confined zones which we call unconfined zone, which we call it as the perched water table, or we call it as a perched aquifers. These are aquifers which is found in the unsaturated zones. Mostly the aquifers are in the saturated zone, or we call it as a groundwater. Here it is found in the unsaturated zone in the form of a bowl-like thing. We call it as a perched aquifer. So you can see here there will be aquicard which will be having, this is a leaky layers, right? Due to this, there some aquifers will be leaked to it. We call it as a leaky aquifers. So we saw 4 points. One is the porosity, saturated, unsaturated zone. Third one we saw about the permeability. Then we saw about the aquifers. Next we are going to see about the storage coefficient. The volume of water released from storage are taken into storage per unit of aquifer storage area per unit change in head. This we call it as a thing. The main thing, it is the water yielding capacity of of a confined aquifer are expressed in the case of storage coefficient. So for example, how much water can be released or stored, or it can be taken out from the confined aquifer, we call it as the storage coefficient. Okay, this is the original water table. This is a 1 meter square. How much water can be removed per meter cube? How much time? For 10 minutes we will take it, the water table after water removal. That we call it as the storage coefficient. Okay, with this I complete this class. In this class we saw about the water table, cone of depression, and what are the geological controls of the groundwater movement, and also we saw the rocks and its properties, right? That we saw. And the next class we are going. Thank you. In the next class we will see about the geological formations and the hydrological cycle. Hydrological cycle they are asking in 1 or 2 question paper. So I will be dealing with the hydrological cycles and going for the geological formation of the rocks. Welcome.